Island nations are often presented as the clearest victims of rising seas. The story is familiar. Sea level rises, islands shrink, nations disappear. But when we examine measured land area data, the picture becomes more complex and more scientific. In today's episode of Sustainability Ventures, we explore why observed island land changes often do not match simplified sea level claims. This is not climate denial. It's climate measurement done carefully. Global mean sea level rise is real and measurable, approximately millimeters per year. But sea level rise is not uniform, not constant, not the same everywhere. Local sea levels vary due to ocean currents, gravitational effects, vertical land movement, and tectonic activity. Sea level rise alone does not directly predict land loss, especially for islands. Many islands, especially coral atolls, are sediment-driven systems. They are shaped by wave energy, storm activity, coral sediment supply, currents, and tides. Islands can shift position, expand in some areas, and erode in others. Stability does not mean stillness. Movement does not mean disappearance. Multiple long-term satellite studies tracking island land area, not elevation models, show surprising results. Many islands have remained stable. Some islands have increased in area. Others have reshaped without net loss. In several Pacific and Indian Ocean island chains, measured land area has not declined, even over decades of observed sea level rise. This contradicts the assumption that sea level rise automatically equals land loss. Coral reefs act as natural breakwaters and sediment factories. Healthy reefs reduce wave energy, produce sand and debris, and rebuild island shorelines. When sediment supply keeps pace with water levels, islands can maintain or expand their footprint. Land loss becomes more likely when reefs degrade, sediment transport is disrupted, and human structures block natural movement. Again, management matters. Flooding events are often cited as proof of island disappearance, but flooding means temporary inundation, not permanent submergence. An island can flood frequently and still retain its land area, remain geologically intact. Confusing habitation risk with land loss leads to exaggerated conclusions. Flooding affects infrastructure. Land area data measures physical existence. These are different metrics. Many alarming claims rely on model-based projections, not observed land change. Models often assume static islands, no settlement response, no human adaptation, no geomorphic feedback. Observed data tells a more nuanced story. Islands respond dynamically, feedbacks matter, and outcomes vary widely. Models are tools, not measurements. This does not mean island nations face no risks. They face flooding challenges, infrastructure vulnerability, and freshwater stress. But framing them as inevitably disappearing undermines adaptation planning, distracts from practical solutions, and replaces resilience with fatalism. Effective responses focus on coastal management, reef protection, infrastructure design, and real monitoring, not assumptions.
island nations are not vanishing because sea level graphs say they should. Measured land area data shows complexity, variability, and adaptation. Climate science advances when we compare claims to observations, not when we repeat simplified narratives. This is Sustainability Ventures, where climate risks are assessed with evidence, not exaggeration.